Good morning, good afternoon, good evening, depending where you're joining us from. We are here for another reveal of a Wizer CTF, this time on number 15.
Yep.
Just to remind all of you, Wizer CTFs are made for developers mostly, even though we have tons of from the hacker community trying to solve this, and it's actually pretty fun to see how they're doing versus the developers. But the whole idea here is to sort of give developers an opportunity to try to hack some code so they can sort of develop the attacker mindset, right? It will really help them in understanding how to write secure code. So this is part of our secure code training. And we have a community edition. This is the community edition. This is a retire challenge. Every other week, we release a new challenge and we retire one challenge. So there's always 6 active. Later, when we wrap up, we'll show you how do you get access to this. But for now, let's review challenge number 15. Itzik, the floor is yours. Please explain the challenge and how do you hack this code?
Absolutely. Thank you, Gabby. So first of all, this is a login page, something very simple. And you are required to, through API, log in as an admin, as a person named Gabriel Tensi. That's your goal. And you see that there's even a UI here. So if you go to the UI, very simple, username, password. Okay? So let's review the code quickly. Okay?
So basically, I need to bypass this. I need to bypass this login page and get in.
Exactly. I don't have any user. I'm not starting from any user. I need to log in as a user without having any user. Okay? So that's the goal. So if you scroll down, many of you sharp-eyed developers will identify very quickly that there's probably an SQL injection bug here, okay? So there's a username. Nobody's actually sanitizing it, but there's kind of like it's incorporated in this SQL query. That's a first candidate we'll look at, okay? However, the exploit is tricky on this one. It's not enough to just identify that it's an SQL injection. Why am I saying that? Because if you go to the login endpoint, you will identify 2 important things. One, the password is really strongly hashed, okay? So the encryption is a bicrypt encryption with salt. So it's not as easy as the MD5 examples that we found, that you could go to a rainbow table and find a translation. This one, you won't find any translation. If there's a password, especially strong, but not even, okay? You won't be able to bypass the bicrypt. However, you will see that that's not the barrier. It's not a barrier. And then another thing that the developer has done here, validation after the fact, after retrieving the record, is that they made sure that the length of the rows is 1. So there's only 1 record that returns, okay? And so that makes it harder for us to take the approach of, we'll do select all. We'll get everything, and we kind of like see all the database. Make sense so far, Gabby?
Yeah, so this is not this simple or 1 equals 1, right? That people attach to the end.
Exactly.
The developer thought about this, right? So the developer tried to protect this code with strong encryption and with making sure that it's only 1 record being returned.
Right. In short, after the fact validation. I got the record. Now I'm validating that what I got is correct, that it's only 1 and that the password is strongly encrypted and shows correctly. Now I take the password and I compare it to the row that I got. And if they're identical, great. Now we know that we have the login record. Make sense? Great. So how do we bypass that? Okay. So let's move on to a postman. So this is without any kind of like further ado, this is a solution, okay? If I run this, I will get the record for Gabriel Tensi, which if I use in the login page, I can show you later if we have time, that actually logs me in as Gabriel Tensi, okay? However, you will see very quickly here that I created my own query. So I took the approach here that, first of all, I terminated the username. So the value of the name, username, is first terminated, and then I added a union select with all fields being literals. What do I mean by that? The ID, then the name, then the password, then the admin, kind of like role, sorry, then last name, and then first name, okay? And also, I provide a password of my own. I provide whatever I wanted. Okay. And how did I do that? The key is that we can bicrypt based on the algorithm that we're looking at in the code. Since we have the code, we have access to the code. We can do exactly the same online. How do we do that? We open a browser and we look for bicrypt generator with salt, which is the algorithm we're using. Any generated will work here. Okay, this one, for example, right? I will go. Oh, I need to view a short video. That's okay. So I will go and I can do whatever password I want. Let's say ABC, right? Salt 10. I'll do exactly what the code does and generate. And now I have a bicrypted, encrypted hashed password. Okay. So I can take that and select it as a literal. So if you look at what we've done here, okay, is I picked my password, DEF in this case, and then encrypted it using one of the online encryption, mechanisms. And then when the code comes to this code comes here and tries to compare, okay, the password that I provided with whatever the encrypted password came from the database, that method compares bicrypts, it will find that it's identical. Make sense?
Yep. I think.
So then I make sure that I have only one record, and the record that returns actually gives it to me. There are a couple more challenges here that are a little less, kind of like vulnerabilities, but it's part of the hacker's mindset. Because how the hell do I identify the order of the fields, and how the hell do I figure out what what type of format do I need to provide here? Nobody tells me that. No, okay. So there are ways to do that, to identify which format. For example, if you go to the login page and you go to the inspection, you can find the code, even if it's React.js or Next.js, and you can go and find and see that actually what the developer has done is they created a JSON stringify of the form. So JSON stringify is name parameter value, name value is an array, right? So now you know how to provide the values. And now if you want to identify the order of the fields, the best way is to just provide one field. For example, let's say I don't know how many fields are returning with the select star. So I hit send, and it will tell me, hey, the number of argument is different, or number of columns is different. Then I can do 2, 3, 4, 5, 6. Once I stop getting errors, I know that I'm the right number. And then the order of the fields, again, I can try that, this, and at the end, I know which the most important ones are the name, first name, last name, and password, so that I can compare the right password. Make sense, Gabby?
Yeah.
Not too difficult.
Is there a way to hide this information so it will be harder for the attacker to try to figure it out, the error messages?
So no, I wouldn't. Like, that's obscuring. Again, this is kind of obscured. Even if you obscure the client code even further, obscuring is not enough, because you can still disassemble it. The JavaScript, the browser should still run it, right? Needs to run it. So there needs to be logic. So trying to hide it makes it a little bit harder. It's kind of like WAF, makes it a little bit harder. It raises the bar for complexity. Even here, it's kind of obscured because the Next.js is not very straightforward. This is not my code, right? This is, you see that arguments are being transferred and flattened. They are numbered. It's not my code, but it is clear enough for me to understand what the hell is going on. So even if it's hidden, the browser shows it to me. The code on the server doesn't need to be open. I mean, in this case, we have access to it, so we can see it. But even the code on the server, there are ways to kind of like try to understand what actually is going on there.
Okay, cool. So let's move to the key takeaways. And how do we make sure this doesn't happen?
Absolutely. So there is a great article here, a write-up, which walks you through whatever we talked about, everything here. We won't repeat that. However, the takeaways are also here, and let's talk about them quickly. So first of all, there are takeaways for SQL injection that I'm not mentioning here, in here, which are the standard ones. Instead of using, just a string, try to use or always use parameterized queries, or an ORM, which is bulletproof almost. Yeah, you have to be careful. There's ORM injection as well, but ORM doesn't let you do those things for sure. And or a solid store procedure can help you as well. So those are the takeaways to how to avoid SQL injection risks. But here the takeaways are more specific. So it is not enough to have an after-the-fact validation to prevent SQL injection. Okay, because hackers, the mindset is, how do I bypass the way that the code is actually validating the return? As you can see here, it's just all literals, just bypasses it. Never count on, okay, I'll do the query. Doesn't matter if I have the SQL injection. And after I get the query, I'll start validating and making sure that things are right. Okay, so that's a very important one. It's not enough. It's not a good method to rely on after-the-fact validation. And the second one is more on the encryption. The fact that I have strong hashing, if I have other things that are wrong with the method the application is created, such as SQL injection, the fact that it's strong hashing is not good on its own, right? It is a very good hashing algorithm, like bcrypt plus salt. You can add pepper, it will be even stronger. Perfectly fine to have bcrypt and salt. Good enough. However, it's not enough if other doors are open. In this case, the SQL injection with literals, because someone can bcrypt and then come back and provide it as literal.
Yeah. Okay, so I think this is a prime example of why SQL injection is still around, 20 years later from the first day it was introduced. Even though people know about it, and we can definitely see that the developer tried to protect against it, if it's not done right, then there's always bypasses. So you really have to understand how the attacker thinks and not patch it, but actually eliminate it from the root, and not try to come up with different patches or stuff like that. So this was a 3-pepper challenge.
Yep.
And and I think it's these challenges are really great to run within your company. Again, there are, I think, 35 right now. There's
38.
a lot,
38 tomorrow.
38. And by the way, we had an amazing...
Sorry, not tomorrow, on Thursday. Sorry.
We had an amazing CTF challenge over the weekend.
Yep.
Is it still open to try it out, or is it?
Right now we reopened it in practice mode. I can go there. So if you're logged in, if you created a user, great. If you haven't created a user yet, you can still do so. And now it's open in practice mode. So the game is over, but it's in practice mode. You can play the game. We opened it up for a lot of time. And right now you see the dashboard hasn't changed because I just opened it literally a few minutes ago. And
Gotcha.
so people can go ahead, and if they haven't solved it, create a user, or if you have a user, you can continue to play here and play, get the flags. So this
challenge number 6 is one of the hardest ones, right? This one was really challenging.
Yes, it's one of the harder ones that we ever had. If you want to challenge yourself, don't look at the videos, and because over there we're providing heavy hints and actually going pretty much all the way, but it's still hard to do. I mean, even in practice, if you have all the tools and you understand what to do, it's still going to take you time to understand exactly how to do it. With that being said, this is really a great one because it's not only requiring you to understand what the vulnerabilities are and how to exploit them, but also some forensic knowledge and understanding as well. Try to kind of like track back ways of doing things, okay, and iterations of requests. So this is really
so as you can see, only one person was able to solve this one, right? Stuart.
Yep.
Which was amazing. Like, we didn't even believe anybody will solve it in 6 hours. We're actually very happy someone did, so people won't come back at us and say this is not working. So
not solvable.
Yeah, it's not solvable. So it is. As you can see, one person solved it.
Exactly.
So give it a go if you want. But again, I would start with easier ones. And we have ongoing. This was a CTF Blitz. So this was like a 6-hour tournament with prizes. but the community version, the regular wizer-ctf.com. This one, can you go to the latest one? Yeah. So if you go to the latest challenges, this is the latest one, and then you can go back and see.
Yeah, you have more.
This is one paper. There is so you've got here something from everything. So yeah, go ahead, play with it, or challenge your team with a tournament. This is one of the best ways to learn how to write secure code. Like seriously, we also have training videos, everything you can imagine, but from an actual, hands-on, I think this is the best way to practice, what you've learned.
Yep.
Cool.
Exactly.
That's it. So, Itzik, thank you very much for. And by the way, Itzik is also responsible for writing, I think, 90% of those challenges. So it's you can reach out to Itzik on LinkedIn if you have any questions. There's also a Discord. So you can join our Discord. There's many people there already.
Yeah. Okay. This one doesn't. Yeah. For some reason.
And join the community and enjoy playing those CTFs.
Thank you very much. It's been fun. It's always fun.
Take care. Bye.
Bye.